usual, I'm only recording my audio and the screen that I'm streaming. You guys won't be on it, the recording at all, if that's something that you're concerned about. If you do have questions, I can still hear you, so just, feel free to ask questions whenever, or you can use the chat. So we're going to talk about JavaScript debugging today. We're going to show some examples. Um, but first, let's talk a little bit about the history of debugging. So the computer bug is a term that was coined by Grace Hopper. Grace Hopper was a computer programmer that was responsible for a lot of the early development of computer programming languages. A lot of what we do today is kind of because of things that she wrote along with her colleagues and other people at that time. And she also created the first bug or logged the first bug. And so there's a picture of it in here somewhere. There it is. One of the things we'll talk about is using the console, and there's this method we can use called console.log, which logs information into the console. And that comes from this history of keeping a log. Programmers used to keep these very detailed logs of the programs that they would write and what the results of running the programs were. Because back then, at this time, programs were run on mechanical machines. They didn't have the same type of computers that we did. So, you couldn't like write notes in a Word doc while you were running your program. You had to write notes. You had to run your program through little physical punch cards, and then you'd write notes to say what happened. And this when there were problems, they would write it in the log and try to talk about what those problems might be. And a lot of the time, they were mechanical or electrical problems. And so you can see here there's a moth that's taped into this log, and it was stuck in one of the electrical relays and caused an error in the program. And so this was a literal physical bug inside of a mechanical computer that was causing the program not to run correctly. And so this is actually where the term bug comes from. It's when there's something in our code that is causing our code not to work correctly. Um, so that's kind of what that term means. It gets used a ton these days. We talk about debugging, bugs, and when we talk about it, that's kind of what we mean. It means a lot of different things, and we'll talk about some of the differences, but that's really what we're talking about is when we write a program, we run the program, and it doesn't work the way that we want it to. So one of the things about JavaScript that makes it's kind of a double-edged sword. It doesn't have very many fatal errors, and a fatal error is an error that causes your program to completely stop running. And so that type of error makes your program not run. You won't see anything on the screen, but in some ways it's more useful because if your program does have an error, you want to know and you want to fix that error. So non-fatal errors are errors that make the program not run correctly, but it doesn't break the execution of the program. So your program is still running, but it may not be doing what you want it to do. A lot of other types of languages have much more fatal errors. So meaning if you get something even more insignificant wrong in your code, your whole program will stop and say, you messed this up. And so it's a double-edged sword because in a way, it makes it a little bit easier to learn because you're not constantly having to deal with errors for every little tiny thing. On the other hand, errors are useful feedback for learning. If you get an error, it tells you that you got an error, that's a way of learning where you made the mistake and how to fix it. So that's one kind of like double-edged sword again with JavaScript is intended in many ways to be used by non-programmers or beginner programmers or people who are not computer scientists, people who are not concerned with like memory management and database structures and things like that. Although in present day we do use JavaScript for a lot of those things, but when it was first created, it was really geared towards people who were only making stuff on the internet and specifically making like animations and interactions on web pages. Um, so that's kind of why that is, and it's a good thing to know about. So when we are writing code, we always want to have our console available. And we've seen this a bunch of times already, how to open up the JavaScript console. Here's the key commands again, command uh, uh, Option or Alt J on a Mac, which is what I'm on now, opens up that console. Control Shift J on a Windows if you're in Chrome. That is. The other browsers have consoles. There's different ways to get to them. There's also, of course, going to the Tools menu. Actually, I don't know if my menu will pop up on the screen, but if you go to the menu and go to More Tools and go to Developer Tools, you'll see that again. One of the nice things about P5 is that it actually has a console built in here. So that way we can write our code, we can view errors in the console, and we can preview our code over here. So it's that's what it means when we say integrated development environment, which is what this website is. All the tools we need are part of the environment. So you can open the console and it does work. You can see there's some stuff going on here, but if I had an error in my code, like something like that, you can see that the error shows up in the P5 console, and it also shows up in the regular browser console. So, you can use, obviously, since we already have a console here with P5, we don't need to have this console window open. But most of the time, if you're editing something outside of P5, if you're just making a regular website, you might be using VS Code or Sublime Text or something like that. It's important to always have the console open. So that's what I always say. I always have the console open if I'm developing something. So I'll see errors as soon as they happen, rather than running my program, seeing what's going on, and then saying this isn't really working, and then having to open the console. If I have the console open all the time, I'll always know if there's an error before I have to discover it. So it's easy to create an error. There's lots of things that are errors. If I go over to the console and just hit X+1, this is what's going to happen. I'm going to get this big red X and this red text that says X is not defined. And so we learned about variables in our last class. Basically, what this is saying is that we didn't create the variable X, and we're trying to use a variable called X, but it doesn't exist. So that's what this error is telling us. X is not defined. So that's what it looks like when you get an error. Errors are always going to be red in the console. There's also warnings for things that you're kind of like not supposed to do. You can ignore those. You probably actually won't get very many of those at this point in the type of code that we're writing. Um, so that's what an error looks like. And the other thing is that it'll usually tell you where in your code it is. So this is the console of this website, so it doesn't really know because I'm just typing directly into the console. But for example, if I had a P5 sketch open and I went into setup and I just had a line like X+1 and I hit enter, the nice thing about this error, so it says the same thing, X is not defined, but if I click on this little red arrow right here, it actually tells me where to look for that error. So it says it's on sketch.js, which is the file I have open right here, and it says line 3. And so I can look at 1, 2, 3. Here's line 3, and it even tells me where it is. It says this 3. So this first 3 is line 3. The second 3 is how many characters in. So we can look, and it's 1, 2, 3. So that's what my error is telling me. P5 also adds their own errors. So this isn't something that will show up, obviously, in a normal JavaScript environment. You don't see anything else here. But in P5, because P5 is geared towards learners, they actually have more information about the error, about common errors. Not every error, but a lot of common errors. So it tells you a little bit more about what's going on. It says X is not defined in the current scope. If you have defined it in your code, you should check its scope, blah, 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 blah. That's actually probably more confusing, but and then they have an example where it talks about variable scope. This is actually something we'll talk about a little bit more probably next week. But so P5 gives you a little bit of extra information. So, if I do something, that's nice because if I do something like I spell ellipse wrong when I'm trying to draw a circle, P5 is actually going to say, they actually see, okay, they were trying to write ellipse, but they wrote ellipse with one L instead. So P5 actually kind of knows obviously it knows about its own language, and it'll give you little hints about what to fix and what you might be missing. So this debugging project is a little bit easier now that we have the P5 IDE. When I first started teaching this version of the class, which is relatively, I think we've been doing it since like 2017 or something like that. We were doing everything in a text editor, so we didn't have this extra information. Okay, anyway, moving on. Okay, so how to debug. So this is just kind of like a general approach about what you want to think about, what you want to do if you have an error, and how to fix it. So the first thing to do is just be like, okay, I have an error, that's fine. This probably, I don't know if this will make a lot of sense because you guys probably haven't encountered any really frustrating errors yet if you just started programming a couple of weeks ago. But eventually you'll get to the point where you have an error that you have no idea where it got there, and you'll spend hours and hours trying to figure it out, and you're going to go nuts. And then some other person, you'll get somebody else to look at it, and they'll say like, oh, you spelled this word wrong or something like that. It's very common experience that we all have, multiple times. So the first thing to do is just to kind of like take a look at it. Don't be upset. If you don't see anything when you run your sketch, it's there's a reason why. You just have to take a second to figure it out. And a lot of times, taking a break is the best way to do that. So the first step, we have to figure out we have to first frame the question. So a lot of times when students first start programming, they'll come to me and they'll say, there's nothing on the screen, or it didn't work, or it didn't do anything. And the first thing we have to do is we have to frame the question of what did we expect to happen and what happened instead. Sometimes that's a good way of reading through the code and saying, well, I thought it was going to do this, but actually something else happened. That's also a good thing to do as you're first learning to code. A lot of what you're going to do is take examples that I've written in class and change them, copy examples that you find on the P5 website or Stack Overflow. That's a natural part of learning to code, is looking at other people's code. So if you're debugging some code that you didn't actually write, you're going to have to think about, what is this supposed to be doing and why isn't it doing that? So we're going to ask ourselves, what did I expect to happen? What happened instead? So then the first thing to do is check the console. This will tell you if there are technical errors, okay? So one of the things we can start to differentiate between is technical errors and conceptual errors. Technical errors are misspellings or, typos, things that make your code not work for a specific reason. Conceptual errors are when we think our code is supposed to do something, but it doesn't do it, but there's no actual red error or technical error that has appeared. So the first thing we want to do is look in the console, and that'll tell us if we have a technical error. If there's a big red text there, that means something's wrong. If there's not, that means we have a conceptual error. We have to go back and look at our code and try to figure out why it's not doing what we want it to do. So one thing, with the console, it's going to have errors, and it's going to have the P5 errors sometimes. So sometimes it looks like there's more errors than there really are. Like if you have a bunch of errors stacked up, you may see like 10 errors in a row, but you only want to look at the first one because that might be causing the other ones. So just that's the first part, is look at the console, see if there's technical issues, then reassess. Okay, so then we have to start testing parts of our program. And this is where the console.log function is going to be very, very useful. So let's say, for an example, we have a variable. Okay, so let's say I have a variable and I say variable x equals 200. And then I'm going to draw an ellipse at 200, or at x, 200, 200. Okay, so that's what my program will look like. Very, very simple. But let's say at some point, and this is going to be a little bit goofy, but this is the type of thing that might happen with a bigger program that has a lot more going on. Let's say at some point, without realizing it, I set x to 600. Okay, so now I have a conceptual error, right? Let's hide this so it looks like I don't know that I did this. Okay, so I'm looking at my program. I said x should be 200. I see the canvas. I'm trying to draw an ellipse at x, but there's nothing there. Okay, so the first thing I would do is I would check the console, but there's no errors in the console. So I don't have any errors, but I still don't see a circle. So the next thing to do after you've looked in the console and there's nothing there is to start logging the values that might be causing an error. So there's this great function called console.log. It just looks like that. And you can have a parentheses at the end, like you do with ellipse or rectangle or whatever. And inside that parentheses, you can put anything you want, and it'll print it onto the console. So it's really, really useful. I can put X in there and then run my code again. And there it is. It's showing me that X is actually 600. It's not what I thought it was. So then I can, now at least I know what the issue is. I know that X is not the value that I thought it would be. So now I can start to go back through my code and say, okay, at what point did I change X? So the nice thing about console.log is I can also add little messages in here. Like I can say, X and then put the X of value after the value of X after a comma. So that way, if I'm logging a lot of different stuff, I can, see, I can label different things. So maybe I had another variable called Y and I can put Y here. And I don't actually have a variable called Y, so I'm not going to put Y there because that would create an error, but let's just put 200 just for the example. So now you can see in the console, I have these values. If I don't put the little label there, I wouldn't know which 200 was the Y and which number was X and Y. So putting little labels in the console is really helpful. All right, let's stop this and clear that. So that's console.log. Again, you can put lots of different stuff in there. So I would recommend just, using it. Just make sure that you get the syntax right. So if I put console.log here, I can write messages. So I can put in quotation marks to make a string and say hello. And then I can put a comma and put other things. So I can put X, I can put a number, I can even put functions. Like I can say what's setup. And so I'm going to log all this stuff. So here's the message hello, that's my first part. Then the value of X, that's the second part. Then I did 400, that's this part. And then I actually log the setup function. Maybe I want to know what that function is. And here it's showing me it's this function, it's got a constructor, blah, blah, blah. This actually doesn't show me as much as what I would see over here. Yeah, this in the JavaScript console, it actually shows me the whole function. I don't know why P5 makes this smaller, but whatever. Okay. So that's console.log. Again, it's really, really, really useful. Yeah, and it's a good thing to get in the habit of using. Okay, so if you tried that and you still couldn't figure it out, you want to start looking at Google or Stack Overflow, doing some of your own research. So Stack Overflow, if you've never been there before, is a website where people ask questions and other people respond to them. And it's mostly focused around developer stuff, and there's a ton of JavaScript stuff on here. And you can really honestly find so much stuff. Like let's say I had my error from before. I'll just say X is undefined and then write JavaScript. Oh, I have to verify myself. Okay. And so then we're going to see all these different examples, and we can see, we can look at these and figure out what matches our question. And if you just Google random errors, if I write JavaScript X is undefined directly into Google, one of the things you'll notice is that there's going to be, actually, it's usually the first one, but it's a little bit down here. Usually the first result is going to be Stack Overflow, but this one is down a little bit farther. If it's a little more obscure of an error, you'll probably see the Stack Overflow first. So that's a third step. Do some research. Just go online, Google the error, or describe the error. Sometimes describing the error is important. And another thing to make sure is that your program is not universal. So some parts of your program are, just general parts of the programming language, but other parts are things that you came up with. So for example, if I have like a variable called, my cool variable equals 10, my cool variable, most people are not going to have that in their program. So if I Google like my cool variable is undefined, this will probably actually turn up basically the same stuff because it's such a common error. Um, but if you have things that are specific to your program, you're not going to find them as easily when you Google stuff. You want to kind of abstract what is universal. So is undefined and JavaScript are the two kind of like parts that I want here, and that's going to help me, find a good answer. Here's actually a good Stack Overflow. How do I check if a property in JavaScript is undefined? And here's some code I can use. So that's what we want to do when we are doing some research. So then after we do our own research, then we ask somebody else. You can ask me. I've seen these errors a million times. I usually will know immediately what it is. But sometimes there's obscure errors that I won't know, and you could post it on Discord, and maybe some of the other students will look at it and they've seen it before. But getting somebody else's eyes on it is a really good way to make sure that you're not missing something obvious, that you've just been looking at the code for too long and you just don't see it anymore. Then finally, just take a break. I can't tell you how many times I've spent hours trying to figure out a bug that doesn't make any sense. And then I finally give up and go to bed. And I woke up the next day and then I just immediately realize what I did wrong. Sometimes I dream about it and realize what I did wrong in my dream. It's just part of the process of programming. And it's very hard to take a break when you're frustrated and you're like really determined to figure something out. But if you can remember and remind yourself to just take a break, even if it's just a 2-second break to, go to the bathroom or get some water or whatever, that kind of like resets your brain a little bit. And that can be very helpful. Okay. Don't delete your code. This is another thing. Students are always like, I had this error, but then it's gone, so I can't tell them what it was. So don't just delete your code. P5 is really easy. If I'm doing something in P5, it's so easy. I don't have to like save these files on my computer. I don't have to keep track of where they are. So just duplicate it. So if, save this sketch, leave it as it is, just duplicate it. Then you can do whatever you want. Then you have a copy of the error that you are getting, so you can go back to it later. So don't delete your code. Every error has a solution. It's just a matter of figuring it out. Don't delete your code. This one isn't as relevant anymore because we're working in the P5 editor. But another thing is to make sure you're editing the right file. This is more of an issue. It really isn't an issue anymore because we are using the IDE, so ignore that one. So there's a JavaScript console. Just a reminder, you want to have that open all of the time. And then here's a few kind of common errors you'll run into. And the thing is with these errors, JavaScript will give you some information about what's happening, but it doesn't always tell you exactly what's wrong because it doesn't really know exactly what's wrong. It's telling you what it's getting wrong, but it doesn't know like in plain English what's wrong. So you can kind of look at these different errors and try to figure out based on it. So one is a syntax error. That's if if you say like variable x equals 1 plus 1, but then you forget the plus and you try to run this, you're going to get a syntax error. So basically you have a number followed by a number without any operator or anything in between. And so that doesn't make sense to the compiler. So it's going to say that's a syntax error. Reference error, we've already seen. If I say what's y plus 1, y is not defined, so that gives me a reference error. Failed to reload resource, you're going to see that a lot. Again, with the IDE, we don't really have to worry about this. But when we used to have files in our folders that we had to upload, we used to see that error a lot. Probably won't see that as much anymore. And then nan is not a number. If I say something like 10 plus 1, or no, I have to do like times 1. I'm going to get nan. Nan's not red because it's actually a value, which is kind of annoying, but it's like a null value. So it's not a real value, but it's used by JavaScript as a placeholder. If you try to do something that you can't do numerically, it just tells you not a number. So that's what that means. Okay, so we are ready for our debugging challenge. So I'm going to go back to the schedule for a second to week 3. And so basically what I have is a debugging exercise, and it's just a P5 sketch. So I'm going to put this in the voice chat. And what you are going to do is open this on your P5 account. The first thing you'll do is duplicate it. So just go to File and click Duplicate and make a copy. So you have your own copy. And then this program has a bunch of bugs in it, and you can read through it and you can run it and you can fix the bugs. And when you're done fixing all the bugs, you're going to have something that looks like this. If it doesn't look exactly like that, that's okay. But as long as it looks pretty close to this image, then you're good to go. So there's some technical errors in here. There's some conceptual errors in here. So there's a variety of different issues that you'll have to kind of fix. Yeah, that's kind of the idea. So we're gonna work on that for the rest of the class. We can do it together. Like you guys can work on your own, but if you have questions and you want to ask the class and other people have gotten there, um, already, they may be able to help you. So if don't be shy to ask questions. When the line turns yellow, is it corrected? When the line turns yellow. I'm not sure. It kind of depends. I'm not sure which yellow part you're talking about, if it's like the function part or which part. But if you want to show me in a second, we can look at it, where the numbers are. Oh, over here? Mm, if it turns yellow, when does it turn yellow? Um, I'm not 100% sure. Let's look at it in just a second. Okay, so yeah, I'm gonna stop recording.